From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
Terrible at quoting, Mike. And when you make things for other people, they come along with a drawing or a CAD model, and they say how much to make this. And in fact, my thesis at Warwick, where I did my MBA, was developing a quantitative model to estimate the price of mold tools, because we were just so bad at it that I was convinced. Some people said, well, it's like trying to estimate the price of a painting by the frame it's in. And I was like, well, it can't be any worse than the way we do it right now.
That was Mark Kirby. After graduating from MIT in Aero Astro Engineering, Mark joined Rolls Royce working on air-breathing rocket engines. Before moving to his father's machine shop, Jet Blades, Mark worked his way from CAD/CAM programmer to managing director, making parts for Formula One teams and Rolls Royce jet engines. Mark joined Renishaw in 2013 to head their new Canadian additive manufacturing business and start up their first North American solution center. In 2020, Mark moved to the University of Waterloo's multi-scale additive manufacturing lab to lead industry outreach and training in additive manufacturing. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcast, including Spotify, Apple, Amazon, or Stitcher. All right, Mark, thank you so much for joining the episode today. I think we're going to have a lot of good dialogue and hearing about your career story in additive. So like I do with all my guests, I think the interesting place I like to start is right from the beginning. So kind of where'd you grow up? Kind of what got you on the path towards where you are now?
Well, we've only got 45 minutes or an hour, have we, Mike? It's great to see you again. Yeah, sure. Let's start at the beginning. My kids like to say, it was way back when everything was in black and white. So we'll start at the beginning. When I went to school in the UK, I went to King Edward School, which was literally was hundreds of years old, and I did physics and art. I really liked physics and I really liked art. And in the UK, the only thing you could do in combination with that was maths. And the only career for you then, I make it sound very prescriptive, but it was fairly prescriptive, was you had to be an architect. You do maths, physics, and art and be an architect. And at the time, I thought I really didn't want to be an architect. So when I finished school, I thought I'd had a pretty happy childhood. And I decided to take a year out, and I went to work in a children's home in Birmingham, which is where I grew up in the middle of the UK. It's a pretty industrial area. So, and this was working with mainly single parent families. And I think it was probably where I learned one of my first really important life lessons, which is not every parent loves their child. We often take our experiences, whatever happens to us, we tend to project it and think, well, that's true for everybody. And, like I say, I think my parents love me. And hopefully my mum's listening, and she still does. But that was a really important lesson, Mike, for me, that, not everybody has such a happy upbringing. But during this time, working for the children's home, my parents met some Americans and their kids went to Harvard, and they explained how the US system, you kind of applied to the university, you weren't admitted to a specific program. You were just so optimistically and maybe arrogantly, I applied to Harvard and MIT, and I didn't get in at Harvard, but I did go for an interview at MIT, and I was interviewed maybe prophetically by a guy in the admissions office called Neil Armstrong. It wasn't Neil Armstrong, the astronaut, but most people came to MIT, and you went there as well, Mike. A couple of decades after me, but most people would come along and they would bring their laptop computer that was strapped to their belt that they had made over the summer. But I came along with a lot of artwork that I had done while I was at school, which was pretty atypical, I think, for interviewing at MIT, that, you whop out your folder full of artwork. And I think, I'm not sure why I got in, but I did. I got in at MIT and discovered there that physics actually wasn't what I was interested in, and physics tended to be about things that were smaller and smaller and harder to understand. And actually, what I liked was engineering. So again, I sort of my career has been a progression, a trajectory. And so I did engineering, and then specifically I did aeronautical engineering, and even more specifically astronautical engineering. I wanted to be a rocket scientist. Or
16, right?
Yeah, of course, 16, absolutely, yeah. And it took me a little while to figure this out. So I graduated at least a term late, I think, and went on and did a master's, and had a fantastic time. Had a pretty lousy time, I think, as an undergraduate, if I'm honest. It was, I'm sure when you went, it's no different. I used to come back to the UK and everyone would say, well, what concerts had you been to? And et cetera. So no, I was pulling all-nighters, and, you don't understand. But as a graduate student, I had a good time, and managed to started a PhD. And again, one of the life lessons you learn was that you can't just kind of study anything. You study what is kind of funded. And again, we'll probably come back to this later on. But my prof, a guy called John Hansman, who was definitely, he was and still is one of my heroes. But he had money to study aircraft icing, which is what I did as an undergraduate. And I found quite boring, but even though we got a patent together and it paid for a used BMW when I got back to the UK, he had money to study the behavior of fluids in zero G. And so I started a PhD in this, and then I was sort of like, well, I'm going to be I'm going to be one of the few people in the world who understand how, propellant sloshes around in a satellite. And I thought I might be badly adjusted, Mike. So I sort of joke and say, well, nobody understood my sense of humor, so I went back to the UK, and nobody still does understand my sense of humor. I mean, my kids tell me, Dad, you're the only one who thinks you're funny. And I'm saying, hey, that's all that matters. But I went back to the UK, and at the time, we in Britain, we were doing a program called HOTOL, Horizontal Takeoff and Landing, which was a reusable space plane. Hey, it's funny how things come around, isn't it? We got our TMIS hopefully going to blast off on Monday, and
yeah, I'm actually heading down there.
Getting ready for a hot fire. Yeah, you're going down to watch it, are you?
Yeah, I'm taking my son Hunter. We're heading down on Sunday night, and we'll get up early and watch it on Monday.
Well, it's what a great way to start the week, and I hope it goes well. And again, probably politically shouldn't comment, but our team is maybe I'll be somewhat deprecating and maybe say that's the kind of rocket maybe I would have designed. And these days we've got new things coming along, haven't we, Mike? Which are maybe even more exciting. But it's exciting time. Anyway, I left MIT. I got super lucky in that there was a job for a rocket scientist at Rolls Royce in the UK. And I went there and worked on the RB545 engine, which was a combined air-breathing rocket engine, worked with some brilliant people, Richard Varville, who's about the only guy who can explain hypersonic crossflow to you and make it both interesting and understandable. He and I flew a seaplane back from Finland together, which would take us much longer than this 1 hour, but we'll have that story over a beer sometime. Worked on this space plane for about a year, and then it became fairly clear to me, Mike, that this was never going to get built. Rolls Royce saw it at the time as, how many engines does this program need? And really, it needed to kind of step change in thinking. We're not going to be in the selling engines business. We're going to be in the space transportation business, and that wasn't at the time a business Rolls wanted to get into. So again, arrogantly, I was like, right, if you're not going to build it, I'm not going to stay. And my dad had a little company called Jet Blades, and they made jet blades. They made blades for jet engines, among other things. A lot of people, for some reason, thought we made ice skates. I'm not quite sure, but anyway, we really made jet blades, and we made parts for Formula One cars. And I went there because they needed a CAD/CAM programmer. I didn't know what CAD/CAM was. I didn't know what CNC was. I didn't know anything about manufacturing. But that is when I fell in love with, I'd gone from physics at school to engineering at university to aeronautical engineering to manufacturing. Fell in love with manufacturing, and I'm still thoroughly in love with it, Mike. And that was my education path, and I was sort of reflecting a little bit, like I bet you remember, what was your GPA at MIT? Go on, but it was good.
I tried to hit the bell curve right in the middle, so I was happy if I got it over 3, which was pretty well. Like a B average, I think. Or
B,
like
so 4.0,
yeah,
wasn't it?
So
yeah.
I wasn't top of the class.
and neither was I, but I was, anybody at MIT is, you're in a kind of top X%, aren't you? And when I was young, Mike, I wanted to be able to derive everything from first principles. I was very, very theoretical, very nerdy. I was sort of reflecting on education in general. I know you're really active in this right now, and I was just reading the post that you were doing with this hands-on program with America Makes, and some of the fantastic facilities you're taking people to, and just sort of thinking how maybe we're a little, are we a bit like athletes? And when we're young, sort of we're physically very capable, if you like, and yet when you get older, maybe you're not as physically capable, but you have more strategic sort of nous, and a bit like the sort of player coach type of analogy. Because I was thinking, well, it's been a long time since you had any education, and a lot of what we work on is not just education for the next, the up and coming generation, but what about the generations who are already working and are going to continue to work? And how do we get to where we are today? How do we know the stuff we know? And because the process is a lot less formal once you leave the system. So
where do you think you would have ended up if your dad didn't have the company? Like, would you have found a different type of AAA blades or something like that? Were you was there
I don't know, because it's a great question. I never wanted to work with my dad. In fact, far from it. Dad was a chartered accountant. So he liked making money. And ultimately, it turns out I like making things. And that wound up, if you can make things to make money, then you're doing something right. And for a while, Mike, we did. But we were a small company. We were originally 50 people. We had actually 2 companies. We had Gosford Tool and Equipment, which made injection mold tools, mainly for the automotive industry, and assembly fixtures for the automotive industry. And we had Jet Blades, which was the tool makers in Gosford Tool looked down their noses at what they called the button pushers in Jet Blades, because it was all CNC and all you did was push a button and there was no real skill. So and it was a unionized environment. And despite all of my education, so I'd been to MIT, I got a bachelor's, I got a master's, I got I was a little bit ahead of the bell curve. I got an MBA from Warwick University. And yet 3 years after joining this company, one of them went bust. And I was managing director by then. So, I clearly had to take responsibility and do take responsibility for that. So for all of this education, I screwed up. Was it all my fault? No. But, it was kind of another interesting and painful life lesson when 40 people lose their jobs. Your family, who's dependent on you, and now, how are you going to support them? You feel a failure. We managed from the ashes to save Jet Blades. We went from 50 people to 10. We were supplying Rolls Royce, who were not exactly happy with reading about, oh, you've gone bust. And we're like, no, that's our sister company that's gone bust. but either way, you were already way too small, and eventually, Mike, we were always going to be food for somebody as a small company, because we bought a couple of $1 million worth of titanium forgings every year. We machined them and sold them back to Rolls Royce. So the titanium forger really wanted to be doing what we were doing. Rolls Royce didn't really want to be dealing with a little company like us. So we were under constant kind of pressure, both from our customer. And again, we had 80% of our business with one customer, which is strategically a bit of a no-no, but really difficult to change. And from our supplier who wanted to take our place. So I was kind of lucky that I managed to sell the company and sold it to a company who wanted to get into aerospace. And my wife, we were walking in the park one day, and she said, "Why don't we move to Canada, Mark?" And I was like, "Yeah, that's for somebody who is Mr. Analytical. I'm a pilot as well. Everything's kind of was calculated. This was a relatively it wasn't an emotional decision, but it was an irrational. It appeared to be an irrational one, but it was, apart from marrying my wife, coming to Canada was, I think, probably and of course having our children, one of the very best things that we did, and that's ultimately where I became involved in Additive. Since I think that was your original question.
And so, you mentioned kind of the sister company kind of failed. You were managing director. Yes. And you had all this education behind you, but realistically, like what were some of the lessons that you either missed or were lacking in kind of the education piece that might have helped? Or is it just one of those things like, hey, like a lot of things aren't out of your control. The only way you get better at this is by doing it. Like you can't see the future. Like there are certain things that are out of your control, right?
Yeah, again, fantastic question. Could I have done anything differently? Could I have, was there a key mistake? I think probably not. I think the path was probably set for us. The businesses were barely making any money, so they didn't have much headroom, when I joined them, if you like. Which is typical of a small business. It's unusual that they're doing extraordinary. Small businesses tend to be small businesses for in fact, there's I think there's a theory about there is no money in subcontracting. I'm not sure that's true, but anyway, we didn't have much headroom, and we took on. We were terrible at quoting, Mike, and when you make things for other people, they come along with a drawing or a CAD model, and they say how much to make this. And in fact, my thesis at Warwick, where I did my MBA, was developing a quantitative model to estimate the price of mold tools, because we were just so bad at it that I was convinced. Some people said, well, it's like trying to estimate the price of a painting by the frame it's in, and I was like, well, it can't be any worse than the way we do it right now. And of course, I was able to prove using Minitab, as of course you do, that I could make a good statistical model. But we wound up misquoting a very large job to make assembly fixtures, for automation in the car industry. And by the time we got into a sort of, I guess, $500,000 project, and discovered that, while $500,000 sounds like a lot of money, when you find out that all of the hydraulic clamps and everything are going to be $400,000, and you really hadn't done the maths properly, and you go back to the customer, who is an automotive tier one, and say, we need to renegotiate, they promptly cancelled the contract on us, which was kind of the death blow for us. So I guess the understanding the power dynamics of small company versus big company, how would you understand that until you've kind of experienced it? And it was a pretty baptism by fire for sure. So should we have done a better job at quoting it? yes, we should have done. Should we have identified the risk? This is a really big job, but small businesses kind of, when a really big job comes along, they normally want to say yes. Whereas when you're a bigger company, you can maybe afford to say no. So, I'm not making excuses, but I think the second part of your, is it this sort of, it's like aviation, isn't it? Terribly unforgiving. It gives the exam first and the lesson afterwards. And I think maybe business is like that as well. This is why you do need to take a few exams and you get some scars, but hopefully you become a better person for it. I certainly think I was a terrible boss when I was younger. I really was. I wasn't a very nice person when I hope my mum isn't listening because she'll disagree with this, but I'm a much better person now. My wife is very human. She has empathy. I had analysis. I always used to joke, hey, I like working with machines because I can make them do what I want them to. And, I still do, I still find that curiously satisfying. People are a lot tougher, but they're a lot more rewarding, when you do that. And, you work in, you fundamentally, your career has been working with people. I'd like, when we get to additives, sort of compare and contrast kind of the choices that we made. But I don't think I could have saved the tool making business. From a family perspective, I like to think I paid my dad back. They're not small amount of money. It cost him to put me through MIT. My parents had never been to university. So, again, it was kind of a big step. But jet blades, we did make some good money for a while. And we did quite a lot of things right. Dad was a visionary. He put in CNC equipment. He put in CAD CAM. He put in BS 5750, which was ISO 9001 QC systems. He put in all of the right technology, but then ultimately I became the one who sort of figured out, how do we now really use it? So I was always more of a Luddite, not a Luddite, but I was more conservative in technology choices, even in flying. Like we had an airplane and we needed to update the avionics, and there was something called area navigation, which was the VOR needles. It was sort of analog steam-driven stuff, but it was the gold standard in flying. And I was like, well, that's what we need, Dad. And Dad was like, no, we should put this new GPS in. I was like, oh, we should. And of course, he was absolutely right. The GPS was amazing. So again, sort of interesting, isn't it, Mike? I was maybe I'm doing a great character assassination job of myself, but I think I'm just trying to be honest and say that we're the sum of our experiences. And Dad had part of his DNA was making these investment decisions, which were gut decisions. And again, a lot of what I deal with in my additive career is about adoption of technology and how do you make those kind of decisions? And Dad had this ability to look at things and say, yeah, I think we should do that. As a small company, sometimes you inherit your mistakes, whether they're people or machines. Neither of them are easy to change once you've made those decisions. So anyway, reflections from the early days when everything was in black and white.
Yeah. And so kind of as we move on in your career, kind of where did the additive piece come in?
Where did the additive piece come in? Well, again, it was a little like a joke. I said yes, thinking how difficult can it be, and not really meaning it. I had worked with Renishaw equipment all of my life. So Renishaw, world-class engineering company who do many, many things. One of which is connected with process control on typically subtractive equipment. I joke and say they make machines that go beep. They make the probes on the machines that measure parts very, very accurately and repeatably. And if you can build a process around that, then you can potentially eliminate people and variation, both of which cost you money. But it's a lot. It's easily said and it's hard to do, and that's what I spent the first part of my career in Canada doing. I worked as a consultant for aerospace companies in the Maritimes. They had made the $1 million decisions on equipment, but again, rather like, my dad maybe didn't know how to use them. And my job was to, again, use them to make money. And I used a lot of Renishaw equipment and software and had a very close working relationship with the people at Renishaw. And that led them in 2012, 2013 to saying they were just getting into additive. And they said to me, hey, Mark, what do you think about joining us and heading up additive for us? And as I said, I said yes, not really meaning yes. But I never really looked back. I was still living in New Brunswick, which is on the east coast of Canada. Renishaw and, a lot of manufacturing in Canada is 1,500 kilometers to the west. It's not a very easy commute. I joined Renishaw 2013. It was very early. It was very early days. And I think, again, my career has been, I've worked for the small company. I've worked for Rolls Royce, the larger company. I've consulted for mid-sized companies. Renishaw is obviously quite a big company. And they're all different. They're all different experiences. But it was, how do they describe education at MIT, Mike? What's the famous expression, drinking
from a fire hose?
Drinking from the fire hose. Yeah, the fire hose of knowledge. And boy, the early days of additive at Renishaw was exactly like that for me. And it still is. And I'm sure you find the same thing that there's just so much to learn. And it's far from just technical. In fact, I think probably, my experience in additive now was around, selling $1 million machines. They're not always $1 million, but it always sounds good when you say that. And they are close enough to being $1 million. I know I have all these family stories, but my youngest daughter, Megan, she was like, we were discussing it one day, and I said, Meg, do you really know what I do? And she said, well, it's got something to do with lasers and cats, hasn't it, Dad? And I said, no, there are no cats involved, Megan. And she said, well, that's obviously where you're going wrong, Dad. We did make cranial plates for dogs who had some tumors on their heads, but it was really interesting. I think we put the first laser powder bed machine in academia in Canada. That went into Nova Scotia Community College in 2013. That was a real eye-opener for me. What's it like installing one of these machines in a facility? How do you train people to use it? It's there's the operator safety, and then there's the whole sort of designed for additive piece, and they're two very different but related pieces. So got into it, and Renishaw then set up. We actually set up what was the first solution center in North America, in Canada, which was a facility where we tried to bring everything together to show industry, what does it look like? Because you've got this $1 million machine and you can show people videos, you can show them a catalog, but actually letting them get hands-on with the technology and kind of seeing how do you go end to end was at the time, a relatively new concept. And it's interesting now, Mike, how solution centers, I always got told off because I always used to call it solution center, a singular, and there was no, there's an S on it. And of course, it was all about, it's not just about one piece of technology, and additive still isn't, and I say to people, you really need to have a plan for what you're going to do with that after you've printed it. And, looking at it as a print sits there on a build plate or whatever, and then sort of like, I wonder what we're going to do next. So that's a really bad plan. But you have to have been there to sort of understand, well, what does happen next, and what decisions should I maybe have taken earlier on. So the Solutions Center really brought all of that to life, and it was a very heady time. We were, Renishaw, was successful, has been successful in Canada. It's been successful globally. I think nobody, in fairness, Mike, has been as successful. Who would say we've been absolutely as successful as we want to be? We've sold everything we want. So, in fact, we're sold out. We're not going to sell it. Nobody says that, and
and it's just tough. I mean, it's $1 million machine. It's new technology. Like, there's it's not easy to set up. There's safety issues. There's design issues. There's all the post-processing. And so it's not like,
and people would, one of the things was, what's changed, if you like, from, if we go back 10 years to now. And one of the things that I think is changing is you're not spending as much time explaining, what is an additive machine. Like, nobody would ask you, I think, Mike, well, what's a CNC mill? What does it do?
Right.
What's a CNC lathe? What does EDM stand for? Now, maybe some people are listening to this like, what does EDM stand for? Electro discharge machining, by the way, wire erosion or spark erosion. But actually explaining sort of what additive is takes up quite a lot of bandwidth. And I think, we did spend a lot of time explaining what additive is. And to some extent, as the technology pushes forward, and, I'm not sure it's every week, but certainly every month, there's some new, alleged breakthrough, isn't there? It's faster, it's different. And then we wind up trying to understand, well, I get told off. Now I work for the University of Waterloo. We're not allowed to call it 3D printing. It's additive manufacturing. And, I prefer calling it 3D printing just because, everybody at least has some sort of visual idea of what 3D printing is.
They don't think you're mixing inks together, right?
some weird alchemy. But there are so many nuances on, what kind of 3D printing are you doing? That again, I think we don't shoot ourselves in the foot, because clearly technology does need to advance, and we need to be, we need to do it faster, we need to do it better. And there are competing new technologies, but we're always, Mike, competing with, it's my first question to people is how are you solving the problem right now? We have metal airplanes and we have composite airplanes, and we're very, very good at building metal airplanes. I remember talking to Bert Rutan, did one of the things, I think it comes back to that arrogant streak I've got, but I wouldn't be afraid to try and start up a conversation with people. And I did have a conversation with Bert Rutan, and he was scaled composites, and kind of maybe one of the fathers of composite aircraft. And he said, these days, if we came along with metal and said we're going to build, if we'd never built airplanes in metal and said we're going to build them in metal, and we'd been building stuff in composites, he just said people would say you're crazy to build in metal because of things like fatigue and corrosion. But because we've been doing it for over 100 years, we've got really good at it. And it's the same, additive is always competing with other, we've been making things for thousands of years, and we are competing with that. So understanding in what way is it better? How does it solve the problem? What problem are you trying to solve? And if the problem is, well, my parts are too expensive, and that's, I'm sure you've come across that. It's about an 80-20 rule, isn't it, Mike? Where that's a pretty common answer. And, it's kind of like, well, wake up and smell the coffee. This is, we haven't really got some magic dust in it. Yeah, we can look at a total cost of ownership, and I can paint you a picture where, yes, it's cheaper, but you have to take a different point of view. And then people find it pretty hard to take different, they're like, well, that's not in my budget. So I think cost is still, probably one of the big barriers that we still face to adoption. Cost of the machines and cost, they are still, are they still $1 million machines? And, no, they're not. But they are still not super, super cheap, are they?
Yeah. And this perspective of how you take the long-term view of some of this stuff, right? You need people in companies. They may not, like very often these days, you're not going to be at a company for 20, 30 years. And so you don't get to see the full progression. People want to get their quick win of getting promoted and either bringing in a machine or saying something like that. And you need sometimes the patience of time and seeing how it evolves in the company, and same probably at the university where you're at. And I think kind of getting to the next question is like, these are $1 million machines. It's expensive to invest in if you're a university, if you're a company. But there is this always challenge of like, how do you, like the question I always get is like, okay, how the technology is always evolving. Like, when is the right time to buy a machine, right? If I'm a university, like I want to be on the cutting edge, but I want to buy this 12 laser system and next week it's going to be 25. But there's still useful things for it. Like there's training aspects, there's academic research, but there's always in the back of people's mind that like, I'm just going to wait until it matures.
Absolutely. And I think, as consumers, Mike, we're super used to, whether it's a TV or a computer or a phone, that, if I wait a little bit, it'll get both better and cheaper. So that sort of, I should wait, makes a lot of sense to us as a consumer. I think the counterpoint to that is your kind of learning curve, both as an individual and as an organization, that you forego learning about this technology if you don't get involved with it. So, but sometimes you still don't have to buy in order to learn, and again, it's, that's where universities can provide a valuable part in helping companies understand what the technology can do. OEMs, of course, can play a role in that. But I think going down the learning curve is important, and how do we facilitate that? And if the learning curve is steeper than the sort of Moore's law technology curve, and of course, MIT have written papers probably on both things, but they've certainly written one on the sort of Moore's law for all technologies, which is again interesting read. But I don't have any evidence that one is steeper than the other. I just have this sort of personal experience of how invaluable an organization figuring out, how it should use different, it's just technologies, tools, how does it need to change? We started this conversation with, well, Mark, why did Gosford go bust? What could you have done differently? And really, as a small company, the decision about not dying tomorrow is kind of the one that says, well, I can put this decision off. And I'm sure you experience the same thing in the US with companies sort of wanting to wait, but you can only learn so much from YouTube, etc. Which is why I think whatever you're doing with your hands-on program with youth and presumably with industry as well, in getting them to different facilities. You went to, was it MXD or something the other day? Yep. And just kind of looking at how they've got rather like the solution centers where they're demonstrating how these technologies can fit together. They're not actually selling something. I just wanted to compare and contrast sort of working for the OEM and working for a university. And I like to say that now that I work for the university, I think I have a much more collaborative lens than the competitive lens I didn't realize I had when I worked for an OEM. And I think anyone who's listening who works for an OEM will, you might think that you're completely agnostic, or as agnostic as you could possibly be. And I thought I was, but I realized afterwards that every article you read on LinkedIn, you kind of filter through, how does this affect us? And I thoroughly enjoy the collaborative nature of being a university, despite the fact that, universities still wind up there's still a competition for academic excellence, and it's not all roses by any means, but I think it's a great place to have a broader engagement. And presumably, Mike, I wanted to ask you went to MIT, and then was it Loughborough that you went to?
That's right. Yep. I did the opposite track.
Yeah.
I went back your way.
Yeah. Well, and you went on, you got your PhD, and you were when I first met you, I think you were working with Burton Snowboards, and the apocryphal image I have that I remember was you were designing new snow boots, I guess, to go on the boards, and then you were up in the mountains sort of printing, and I like to think you were sort of printing a new design, and then people would go out and ride it the next day, which sounds like it was sort of a dream job, and yet industry hasn't lured you away, Mike. You've formed 3Degrees. You've been consulting, and I've consulted too, and it's a tough gig. Why did you choose that path, if you don't mind me asking?
Yeah, I mean, that was a good question. I think so. When I was at Burton, I was still doing my PhD. They were kind of co-sponsoring my work, so I got to work with a couple of guys named Ryan Larson, John Cross, who were over at Burton and gave me a lot of my first lessons in additive. We were doing a lot of material designing, testing, things like that. And I always try to time my trips over in the wintertime. But yeah, when that finished, that was kind of around 2012. Additive was still nascent. I think for me, I didn't want to do more like benchtop lab materials work. I felt that I had a gap in, at least I didn't want to go into academia and do teaching at the time. I think I wanted to experience industry, experience business. I'd met my now wife around that time in Chicago, and I wanted to come. This is kind of geographically where I wanted to be. And there weren't that many opportunities here. And I probably subconsciously always had the streak in me where I didn't like being told what to do. In a sense, not that I don't like to work with teams or things like that. It's I think what I've like about 3Degrees and what I've done with the AMX, the training program, and our Trace AM software is I get a lot of optionality. I view having a company that, I make money on this. I mean, the first year I think I made maybe $10,000-$12,000, like not enough really to not a great living, but as it grew and got some more stability with different projects, I think the ability to try different things was what I like, and try different things like the podcast. Like if I were working for a big company or even a medium-sized company, it's not a priority. Like this doesn't make money, right? Like but I like to do it. And so I can justify it in different ways. And I think the other thing is I like the long-term view of what does success mean? I've always tried to take a longer term view. It's like, hey, this thing didn't work out, but it taught me X, Y, and Z. And so I think there's not a outside pressure from an investor or a program manager or something like that is defining what I do every day. Obviously there's pressure. Like,
has somebody come close to luring you away from 3Degrees over the years?
Not really. Andy Snow asks me every time I see him. So
from EOS. Okay.
We have a running joke about it. It's been 10 years. So, I mean, it's I
know, because I met you, you were just starting out. And as you say, the industry was so young, there maybe weren't the opportunities there are today. But being master of your own destiny. Everyone always thinks the grass is greener, don't they, Mike? And it's a tough road to hoe, no matter which way you go. But no, it's fantastic what you've done with 3Degrees, and I'm pleased that the industry is significantly more buoyant today, than it was 10 years ago. Even though, as we say, it's maybe not as buoyant as everybody wanted it to be. But yeah.
And so, kind of as we kind of wind down for the interview, I mean, like, what are you kind of doing today in terms of your role at Waterloo? Like, what are you seeing in terms of the industry and your role in it?
It's still about adoption, Mike, because if people don't use this technology, then there's nowhere for the talent to go. So the university is a talent pipe. It's a combination. It's a talent pipeline. Because research without people doesn't happen, does it? So even though I think there are different schools of thought on what is the function of a university. Is it to do research? Is it to teach students? And I like to think it's both. So my job is working. Typically, I think I sort of have a foot in industry, in the customer camp and in the university camp, in terms of what kind of problems is industry wanting to solve? How can we help, and how can we ensure some kind of longer term benefit, rather than just we figured out the answer to a really complicated specific problem that might, for example, it might benefit industry, but it doesn't have a bigger pull on the kind of ecosystem. So, I like to be involved in projects where industry is looking typically at different technologies. In Waterloo, where I am, we have probably, I don't know, we do literally have millions of dollars worth of different types of equipment, different technologies. And so it's a good way to compare how the technologies perform for industry to get more hands-on. That's something that I am trying to champion at Waterloo. It's not that common at universities for industry to be more hands-on. Sometimes it's give us your money, but we leave us be. I think Waterloo in general has a very strong entrepreneurial kind of DNA. We're in the process of moving to a new facility where all of our equipment will be under one roof. It'll be much easier for us to work with industry there. But we're not. It's a thin line. It's a thin line, as the Pretenders song would go. Between collaboration and competition. It's a thin line between love and hate, actually, isn't it? Is what she sings. But and I think I'm better at walking that collaboration line now. But and Canadians tend to be fairly collaborative in nature, and we definitely need to be, because we're a geographically big nation, but we're a small nation in terms of sort of our kind of internal market, as it were. But we should be able to be agile. And, one of the things about Additive is meant to be, hey, it's agile, it's customized. In many ways, Additive ought to be a sort of perfect fit for Canada, as a tool, if you like. But, again, it's easily said, hard to do. I'm not sure that really explains what I do. I do, I keep my hand in. I do get involved in projects. I like to mentor students. I don't teach, but I think, again, as we get older, we have different kinds of skill sets. So sometimes, I think advice for students is, like, well, you probably should, be on LinkedIn. Because if you want a job, then you should at least have a look around. People should know about you. And even if you want to stay in academia, you probably want to do research with industry. So you should still be on LinkedIn. So But, I started coming back to the beginning, when I went to MIT and I showed them my artwork and I got in there. I think having a breadth of experience and figuring out, we often figure out what we enjoy, Mike, by, maybe sometimes figuring out what we really don't like. And you don't know it till you try it. So I love the fact that, again, you're working with people, giving them hands-on experiences. It's a little harder in Canada sometimes because we're so spread out sometimes to give access to people. But we've got a lot of equipment across the country, and one of the exciting ideas we're trying to work on is how can we move people to different facilities so that they can get different experiences of both, machines, applications, kind of cultures. It's always, as a consultant, I'm sure you find when you go to different places, everywhere you always learn something new. And, it's that immersion experience that you're learning. And that's that sort of lifelong learning experience that we have. So I definitely try to promote that wherever and however I can. And again, this podcast is an example. Thank you for, having the discussion, and, hopefully again, we can see some people who, might not have thought university they may have a fairly narrow view of what a university can do. And again, I think just like maybe you might have had a narrow view of what additive manufacturing can do, you probably should revisit that assumption in 2022.
Absolutely. Well, Mark, thank you so much for joining the show, and hopefully see you in person a few weeks or a few months here.
Thank you so much, Mike. Really appreciate it. Goodbye.